So this is 5.3, number 42. They tell us the function is positive from 0 to 2. So I drew a random function. I don't know what it looks like, but that's my function. And then from 2 to 5, it's negative, so I drew it below. And they tell us the integral from 0 to 2 is 6. So I already know the area of this top piece is 6. I'm going to draw that, put that in there. And then 2 to 5, I know the area of that bottom piece is 8. But let's go ahead and do this. Parte 0 to 5. Golly gee, I don't have a 0 to 5, right? I don't. But I use my property. 0 to 5, I can break that into two parts. I can go from 0 to 2 and add 2 to 5. But 0 to 2, I know is 6. And 2 to 5 is negative 8. So I get negative 2, dun, 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 and we're done. Okay, B, important. You have to understand how or what absolute values do. So we want 0 to 5 of the absolute value of f of x. Well, what does that do to our graph? I'm going to draw it below. What does absolute value do? It takes anything that's negative and flips it and makes it positive. So the new graph is going to look like this, where that has an area of 6, that has an area of 8. So this would be the integral from 0 to 5 of absolute value of f of x dx plus the integral from 0 to 5, 0 to 2. And the next one will be 2 to 5 of absolute value of f of x dx. Well, the first one doesn't change because it's already positive. So that's going to be 2. But the next one, when you flip this up, the net area is going to be positive because the graph's on top now. It's going to be plus 8. You're going to get, whoa, oh, that's 6, not 2. What am I doing? That's 6. 6. See, 6, 6, 6. The answer is 14. I was like, why is my answer not matching? Okay, that's that one. So letter C, you see, I'm going to pull the 4 out in front because that's the property we have. And what's the integral from 2 to 5? Well, 2 to 5, the absolute value, it moved on top. So now it's going to be a positive 8. So it's 4 times 8, or 32. And then they're getting crazy on me. Let me erase all this and go to part D. You might look at D on a test like, what's going on? You got to go back to basics. You learned one of your properties. You can write this as 2 separate integrals. You can break up a sum into 2 separate integrals. Well, here's the good news. You already figured these out. 0 to 5 is negative 2. So this one's negative 2. And you figured out the absolute value is 14. So that one's 14. So you get the answer of 12. El Dano. And I want to make a side note. Some of you might be saying, what does it matter if f of x is negative and positive on those regions? I'll show you why it matters in the absolute value. You might think, that doesn't matter. Here's why it matters. What if they didn't tell you it's negative? So could our graph have looked like this instead? Where the area of this top piece is 6, and this integral is negative 8, right? Well, that could be because of a negative 10 and a 2. So if I integrate from 2 to 5, that would be negative 8, right? But if I absolute valued that, this part would flip up. That would be 10. Now the integral of the absolute value is 12. not 8. So it matters that it was all negative here. Hopefully that made sense to you. I record that. You can go back and watch this. Bye-bye.